In this exercise, we're going to see how to analyze data taken in a lab by taking an average, a standard deviation, and a percent deviation to determine how good our numbers are, and then to graph our results in various ways to try to determine a relationship between the mass of an object and the acceleration of an object that's undergoing a constant force, in this case provided by a fan. I've already entered the data in, so we have 4 mass values that were taken in the lab, and with each mass value 3 trials were done measuring the acceleration of this object under a constant force provided by a fan. So the first thing we need to do is take an average of the 3 trials for each mass setting. In Excel, this is very easy. You could type in a formula that says this cell here equals this plus this plus this divided by 3, but Excel offers you a bunch of built-in functions that allows it to do this for you. So in this case, I'm going to hit the F of X button up on top. This allows me to choose different functions. It usually shows your most used functions first, so average is one of the ones that are pretty close. If you don't see the function you want, you can search for it, and it finds it for you. So I'm going to select average. It then asks you, what do you want to take an average of? And it already tried to make a guess. In this case, it actually happened to get it right, but if it didn't get it right, you can simply just select the values you want to take an average of, and then hit OK. And Excel gives you an average. What's great about this point is that I don't have to actually keep writing equations in for the other trials. I can simply copy this formula. In this case, I Control C. You can right-click copy as well, and paste it into these other cells I want to take averages of. And Excel is built to know that because this average was taken for the 3 numbers above it, well, this average was taken for the 3 numbers above it, and this average was taken for the 3 numbers above that, as well as this one. Now, next thing we want to do is we want to take a standard deviation. And again, the standard deviation allows us to see how good our numbers are. If your standard deviation is small compared to your average, it means your trials are pretty good. It means that they didn't vary that too much. So again, I'm going to use a function in Excel. Another way to use functions in Excel is to type in their names if you know what they are. In this case, I happen to know what the function for standard deviation in Excel is stdev. So you simply hit equals to activate and tell Excel that you are typing in an equation, and type in stdev for the function name, open parentheses, and now select the values you want to take a standard deviation of, and close parentheses and hit enter. And again, because of the way Excel works, I can simply copy this equation I just wrote and paste it into the other cells. So now I have an average for each set of data. I have a standard deviation for each set of data. Now the last thing I want to do is I want to take a percent deviation. The reason you often use a percent deviation is that it allows you to see what percent your standard deviation is of your average. For example, if you measured some numbers and the average was 10 and your standard deviation was a half, well, 0.5 out of 10 is pretty small. It's 5%. So your numbers are pretty good. They didn't vary too much. But if your average was 1 and your standard deviation was 1/2, well, 0.5 out of 1, that's 50%. So that's a huge deviation. It means your numbers probably weren't very good, that they were varying way, way too much. So sometimes it's hard to see if your standard deviation really means that your numbers are good. So we take a percent deviation so we can better determine how good our numbers are. Again, if your percent deviation is usually 5 or less, or around, it usually means your numbers, at least in a high school lab, are pretty decent. So to take a percent deviation, it's simply going to be the percentage that the standard deviation is of the average. So I'm going to hit equals to tell Excel I'm creating a formula. I'm going to click on standard deviation divided by the average, and there's my percent deviation. And in this case, I already have this cell set to be a percentage. If you didn't have it set that way, you can simply hit the percent button in the toolbar, or you can always right click on the cell, go to format cells, and change it to whatever type of number you want. For example, if it wasn't set that way, it might have said something like this in the beginning, 0.0287. And if you want to change it to percent, you can simply hit the percent button and it changes it to a percent. And you probably want to add one more decimal place, so 2.9%. And now I can copy this and paste it into the other cells. And it looks like in this case all my percent deviations are around 5 or less, so my numbers are okay. So I finished analyzing my raw data down here. Now I want to make a table so I can graph my data and see what this data means. So I've already created a mini table up on top in blue that has my 4 masses. Now I'm going to enter my averages up here. But instead of just retyping them, I'm going to actually create another little equation that says that these cells here are going to contain the averages I just found down here. And the reason this is useful is if you made a mistake entering data and you wanted to go back later on and change some of it, you would have to change the data you put in and redo your averages and then recopy it up here. But if I simply say, well, this equals this value, this equals this value, this equals this value, and this equals this value. Now if I did happen to make a mistake and change this is supposed to be, I don't know, let's say 0.09 instead, my numbers on top automatically change themselves and automatically update themselves. Alright, so I have a table. In this case, the masses and accelerations. Now I want to make a graph. To make a graph in Excel 2003, you simply can either hit the graph button or the chart wizard, or you can say insert chart. This is where first time users get tricked sometimes. You think you want to make a line chart because you're going to put some dots and connect them with lines, but a line chart is not that type of chart. A line chart is like a bar graph that lines connect the tops of them. You want to make a scatter plot. I'm going to choose one without lines. Click next, and as you see right now, because I selected no numbers, there's nothing selected here. Sometimes Excel will try to guess what you want to make a graph of, and it'll give you numbers. Most of the time it doesn't guess correctly, so I prefer to select nothing and create the chart all on my own. So I'm going to go to series. I'm going to add a series. So a series is just a set of coordinates or set of numbers. So I'll select add, and it says what is the series of. And it says you can give it a name if you want to, that's fine. But then it asks you what are the x's and what are the y's. So to enter the x's and y's, you simply select in that cell right there and you drag whatever you want your x's to be. In this case I want to put mass on the x-axis and acceleration on the y-axis. So I'll select my 4 mass values for the x, and I'll select my 4 acceleration values for the y. And as you can see up here, there's already a graph being created. I'm going to hit next. In this table you can clean up your graph, make it look pretty, I always say. So this is title be acceleration versus mass. On the x-axis I have mass measured in kilograms. Y-axis I have acceleration measured in meters per second. And now there's a couple other options to change the look of your graph. You can turn on or off axes. I'm going to leave them on. You can change the number of grid lines at this point. I'm just going to keep the major grid lines on. The legend is a little box that tells you what's on your graph. Because you're only plotting one set of data, there's no real need for the legend. If you were plotting multiple sets of data at once, the legend is useful to tell users what each piece of data means or each set of data means on your graph. So I'm going to turn it off right now though. And this looks pretty good. I'm going to hit next. And now at this point you can make your chart as an object in here, which means it'll sit right around here, or you can make it as a new sheet. I tend to always choose make it as a new sheet because it looks better and it looks a little bit cleaner. So I will choose that and I'll give it a name of A versus M. And I'll finish, and I have a chart created. Now at this point you can kind of clean your chart, make it look pretty again. If you double click in the background, you can change the background color, change the patterns and lines, stuff like that. So I'm just going to leave it like this for now. Now the next part about analyzing your data is, so we have some data points. Now I want to try to fit curves to them. So I can already see this is not linear. You could try to fit a line to it, but it's not going to fit very well. In this case I happen to know that this looks like a y equals or y is proportional to 1 over x type of graph because of the way it curves this way. So the goal of this exercise is to try to linearize your data, which is to plot it until you get something that looks like a straight line. because once you get something that looks like a straight line, it'll tell you that your y variable is proportional to your x variable. So I'm going to go back to my data, and I'm going to make a new column. Because I think this graph looks like acceleration is proportional to not mass, but 1 over my x variable, which is my mass, I'm going to create a column that's 1 over m, or 1 over mass. And at this point, all I'm going to do is create a new relationship that says whatever is in this cell is equal to 1 divided by whatever is in this cell. Then I'll hit enter. And another way you can copy in Excel is if you move the mouse to the corner of a cell, it changes this little plus sign. If you click here and drag it down, it'll automatically copy and paste it to the other cells. So I have now a new set of data which is really the same as this data, except for it's the inverse of this. So this is 1 over m. Now I'm going to make a new graph and test my hypothesis that the acceleration is proportional to 1 over the mass. So I'm going to make a new chart, another scatter plot. I'm going to choose without lines. This time I'm going to add a series, but this time I'm going to use for my x values 1 over the mass, and for my y values the acceleration. Right, so far so good. I'm going to hit next. Again, I'll turn off the legend, turn on grid lines, give it a title. So this now is acceleration versus 1 over the mass with the inverse of the mass on the x-axis and the acceleration on the y-axis. Next, again, I'll create it as a new sheet. And hit finish. I have another new graph. I'm going to get rid of the background. So I'm going to choose to make these dots a little bigger so I can see them. If you double click on your data points, you can modify them here. I can change the marker, which is the actual dot. Let's say I'll change it to, I don't know, a triangle. I'm going to make it a little bit bigger, and let's make it red. So now it looks like it could be a straight line. It looks a lot closer to one than the last one did. So to try to fit a curve to this or fit a line to this, I'm going to select my data by left clicking on it. Then I'm going to right click on it, and I'm going to select add trend line. Now there's a couple types of trend lines I can add. Because I think this is a linear relationship, I'm going to choose the linear one. And here's the important part. You have to click on the options tab, and for some reason this is not on by default, but you have to tell the computer to turn on display the equation on the chart. So I'll select that. Now I'll select OK, and it fits a line to it. And if you notice here, it also gives me the equation to this line. And this line fits my data pretty good. I have a decent relationship here. So now the equation says y equals 0.01369x minus 0.0227. But remember, my x variable is 1 over the mass. My y variable is the acceleration. So what this really means is that acceleration is equal to 0.1369 divided by the mass plus this little constant over there. But there you have it. We were able to analyze some data, take averages, take standard deviations, take percent deviations, use our averages to create a plot in Excel of our data initially, go back and modify our data sets, create a new column that we then plot again and to try to linearize it or try to get a linear fit, which we did. We then fit a curve to it and got an equation that describes our set of data.